All right, so let's say we wanted to graph f of theta is cosine of 2 theta plus 4 quantity. Sorry. Let me say that again. How do you read this again?
Cosine times quantity of 2 theta plus 4 plus 1.
Yeah. Cosine of the quantity 2 theta plus 4.
Pause.
Plus 1. Cool? All right, so how would I go about trying to graph this? What do I think this thing involves at the very least?
We have the cosine graph.
Okay, so it's got a cosine wave, right? So cosine looks like this.
But the period is the whole circle graph,
Hang on.
right?
Okay, yeah, so this is doing something to the angles, right? Like that's changing my inputs. How about what's the plus 1 do?
Oh no.
Okay. So at the very least I have an up 1 here. Okay, so if I was going to bubble diagram, right? Well, what's your first step you'd start with? Multiply by 2. Then what are you going to do?
Add 4.
Add 4.
And plus 1.
Then you're going to cosine the thing. Then you're going to plus 1 it, right? So this guy here is up 1. This guy here is your cosine, is your rule you're talking about, right? And then these two guys, what are these? Your plus 4 and your multiply by 2? The plus 4 is a left shift. So that's a left by 4. And what's this guy?
Compression.
So horizontal compression by 2. You guys all with me? And then I have to remember that these happen in the opposite order, right? So I first have to do the left 4, then the compress, and then I can do my up 1 at the end. You guys cool with that? Okay, so first steps first, I'm going to start with my cosine. So there's my cosine. Regular old cosine theta, right? Where's the top and the bottom and this crossing and that crossing?
1 to negative 1.
Okay, top, bottom are 1 and negative 1.
And 5 over 2.
Okay, and the first crossings off the y-axis are negative pi over 2 and pi over 2. Where's this next one going to be? Okay, that's at 3 pi over 2. And the bottom of this bell is at pi. Cool. You guys all good with that? Okay, so that's just regular old cosine. Now, what do I need to do first?
Left 4.
Left 4, right? So what's left 4 going to look like?
Well, you're in units of pi over 2, so you just go left 4 units.
Okay, so I need to move this whole picture left 4 units, right?
Yeah.
Which is going to be a lot like moving my y-axis right. You guys all see that?
Yeah.
So where's 4 to put my new y-axis? Okay. How big is pi, give or take?
30.1.
Yeah, like 3-ish.
Oh my god.
So this is at like 1.5. This bottom of this bell is at pi, right? Okay, so that's like 3-ish. Where's 3 pi over 2? That's at like 4.5, right? So your new y-axis is going to be someplace in here. You guys all see that? So the pink version of this is left 4.
Would you label that point right there? Would you try to find
This
just do-
point here.
Yeah, or
Gosh, I would really love to find that point there. You guys see that? That would be really great. Unfortunately, I have no idea where the hell that is.
All right. Yeah.
We can figure it out. So if I want to go left 4 units, right?
Yeah. It doesn't. I
The x value on the black, right, should be, what, 4, yeah? Okay, so that'd be 4, comma, whatever you get out of plugging 4 into the cosine function, right? So it'd be 4, comma, cosine 4. On my new picture, right, so after I've shifted things left by 4 units, and I have this, got my bell going like so. This dot here is now going to be 0, comma, cosine of 4. You guys all see that? Okay, then I need to what? Horizontal, compress everything by 2, right?
That's the period in half. Right?
Yeah, so I'm going to cut the period in half, right? That's going to be smashing this whole thing in. You guys see that? So this value here, this first crossing off of my new y-axis, that was at 3 pi over 2 in the old school, right? So now what's the x-coordinate for that thing?
3 pi over 4.
Even worse. 3 pi over 2, and then I subtracted 4 from it, right? You guys see that? And then I need to compress by 2. Yeah, so I need that over 2. Jeez Pete's. This guy here is going to be 3 pi over 2 minus 4, right? Then split, divided by 2. You guys see that? Okay. Thank God the y coordinate is easy. What's the y coordinate there?
0.
0. Why?
Oh, wait.
You guys with me on this? Yeah, this is the first crossing.
What is it?
Because it was way over here, right? 3 pi over 2 is like 9 halves, yeah? It's like 4.5. Well, when I moved the y-axis right 4, really that's taking 4 off.
Okay.
So it should be at about a half, right? And then after I compressed by 2, it's at about a quarter. You guys all see this? This is like super annoying, right? You guys all kind of with me on the annoying? Okay, so another way, which is really kind of what I was advertising earlier, is to say, okay, well, what the heck? I'm not even done with this +1 thing, right? So this isn't even a done picture because it still needs to go up by 1. Okay, so we shift it up by 1 and then we'll be done. Another thought you might have is like, okay, I want to know where these crossings happen. You guys kind of with me on that? So this first crossing here, I'm going to kind of look at that and I'm going to think to myself, oh, I don't know, cosine normally starts over here. So there's a crossing at, so where are your crossings normally on cosine? Yeah, they're minus pi over 2, pi over 2, 3 pi over 2. Okay, so let me look at those. I'm just going to take the pi over 2 one to start with. Okay, this is normally where the first crossing to the right of the y-axis is. I'm going to lose the fact that it's the first crossing right of the y-axis, but it's still going to be a crossing. Right, it's still going to cross midline then. So I'm going to take that pi over 2, and I'm going to set it equal to 2 theta plus 4. You guys see that? And really I should maybe say that these crossings are at the midline, right? Okay, so now, can you solve for theta here?
Yeah.
Yeah, right? You subtract 4 and divide by 2, so you get, yeah. So you get theta is pi over 2 minus 4 over 2. Okay, see that? That's going to give me this coordinate right here. That's pi over 2 minus 4 over 2, comma, 0. How do I know it's that one? Oh, I just friggin' lied to you. It's not that one. It's this one. But I know it's one of the crossings. You guys see that?
I mean, if you find one of the crossings, then it doesn't really matter.
Yeah, so you can just figure out which ones it is, right? So the next one, the other one I had looked at was minus pi over 2, right? So take minus pi over 2, set it equal to 2 theta plus 4, solve. You guys notice you're applying the same function every time here? You're going to apply the subtract 4 and then divide by 2 function. So you're going to get theta is minus pi over 2 minus 4 over 2, which is more negative than that one, which clues me in that this one is left of that one. So really, that one's here. This dude there is at pi over 2 minus 4 over 2 comma 0. And then this one's what you'd get if you plugged in 3 pi over 2 and solved. You guys kind of with me on this? So you can use this to chase down your crossings if that kind of thought is a little bit too much.
Since there's no amplitude change, it's just the cosine graph.
Yep, there's no amplitude change, so it's the usual cosine graph move forward and backwards and then up 1. Right, so really if I was going to finish this picture, yeah, this thing, this midline, would be at height 1, right? So I'd go back and adjust my y's, so these are at 1, 1, and 1. And then my axis is actually down here. You guys with me on that? Okay. So this is an alternate trick for shifting. I don't care which one you use.
Does this have to be used anyway?
What? This shifting thought?
Yeah.
Yeah, this kind of thing happens a lot. This is sort of the easiest version of this thing. Normally what we'd worry about is some kind of like long-term trending. I mean,